All right, so let's work on question 30 in the chapter 3 sapling homework. So this question has to deal with, it deals with concentration of an ionic species. So we learned in chapter 4, I believe, about ions in solution. When you dissolve an ionic species like barium bromide here, it will break up into the species for every one molecule of barium bromide that you put into solution. If it's like in the solid form and you add water, you'll get one barium 2 plus aqueous um, cation plus two bromine anions. All right, we learned that in chapter 4. So that this fact will help us with this question because we want to determine the concentration of all the species in solution. So let's read it. So determine the concentration of barium bromide, barium 2 plus, and barium minus in a solution prepared by dissolving 1.8 times 10 to the negative 4 grams of barium bromide in 1 liter of water. Express all concentrations in molarity, and then additionally express the concentrations of the ionic species, the cation, anion, in parts per million, or ppm. So let's just start with this first part. Let's determine what is the molarity of barium bromide in molarity. So again, molarity is equal to, so molarity big M, and also these brackets here, the brackets, whoops, this typically just indicates molarity. So that's like saying what is it, the molarity of barium bromide is this. All right, so let's remember molarity is equal to moles of the solute in question over liters of the solution. So the question pretty much tells us what everything that we need. We can get moles of solute from the grams that of the barium bromide that they gave us, and it told us how much the solution is. It's 1 liter. So let's figure that out. Okay, so to get the concentration of barium bromide, that is equal to the moles of barium bromide over liters of the solution. Also, concentration of barium is equal to moles of barium 2 plus over liters of the solution. Also, the concentration of bromide in this case is equal to moles of bromide over liters of our solution. So with those definitions in mind, that'll help us get the answers that we need. So as long as we can get the moles of the different species, we can figure out what are all of their concentrations in the solution, in the 1 liter solution. Okay, so the first thing I'm going to do is convert grams of barium bromide into moles of barium bromide. So to do that, 1.8 times 10 to the negative 4 grams of barium bromide. Use the molar mass. 297.13 grams is 1 mole of barium bromide. So in that solid sample that we dissolved, that is equal to 6.06 times 10 to the negative 7 moles of barium bromide. That amount of solid got dissolved in, whoops, let's let my computer catch up. I need to come up with a better way to do this. All right, so moles of the substance got dissolved in 1 liter of solution. So that means that the concentration, so now we're in moles per liter. This concentration is of barium bromide And that is equal to 6.06 times 10 to the negative 7 molarity. So there's our first answer. Right? So we will use this definition here of molarity, where it's moles of barium bromide over 1 liter. We're going to use that to our advantage because we know what the ratio between one molecule of barium bromide is, and is a 1-to-1 ratio to barium, and then is a 1-to-2 ratio to bromide. So I'll write that here. So in one molecule or in 1 mole of barium bromide, there is 1 mole of barium cation, but there is also 2 moles of bromide anion. So I got these ratios from the balanced equation of barium bromide being dissolved up here. So you can see that it's a 1 to 1 to 2 ratio. Right? So we'll use these conversion factors to help us get the next two concentrations. So if you start with this number from the previous calculation, so 6.06 times 10 to the negative 7 moles of barium bromide over 1 liter. So again, I'm just rewriting concentration in terms of moles per liter instead of the big M. So I can use that number and the conversion factors that I just got in the above line to get from moles of barium bromide to moles of barium. So here it's a 1-to-1 ratio. So do you really need work to do this? No, but I want to show you how these ratios will always work. So 1 mole of barium bromide is equal to 1 mole of barium 2 plus. So you can see how now these units cancel. So instead of in moles of barium bromide, we are now in the unit of moles of just barium. So now we needed to sneeze. All right, so now we have our concentration of barium 2 plus. And that equals now, it's the same number, so 6.06 times 10 to the negative 7 molarity of barium 2 plus. So there's our second answer. All right, so now let's do the same thing for bromide. So again, I'm going to start with the same number, the molarity of barium bromide that we just calculated. So start with that value. Bromide over 1 liter. So now we just have to use the other ratio. So 1 mole of barium bromide. That cancels. Put what we want on top, so 2 moles of bromide. All right, so now you can see how the units cancel. Barium bromides cancel. Now we're just left with concentration of bromide minus. And that equals 1.21 times 10 to the negative 6 molarity of Br minus. So there is our third answer. Great. Okay. Oh, we're not done yet. So the next question, it says, okay, what are the concentrations of the ionic species in parts per million, or ppm? So I'm going to add another page. Okay, so we want to get to ppm. So ppm of bromide and of barium. Okay, so let's just get a refresher on what ppm means. So ppm just means in a solution where the density of is 1. ppm means 1 ppm is equal to 1 milligram of substance over 1 liter of solution. So you can kind of see molarity, the unit of molarity, oh my gosh, stop it. The unit of molarity is moles of our substance over liters of our substance. So if we take molarity of our ionic species and use the molar masses of each of them, we can get that into milligrams and get to a mass that resembles that of a ppm. So I'll show you how I do that here. So let's start with barium. So use the value of barium, the concentration of barium that we got in the previous question. So let's start with 6.06 times 10 to the negative 7. Yeah, 7. So that's in molarity. That's the concentration of barium 2 plus. But instead of big M, I want to write it as moles of barium 2 plus over 1 liter of solution. All right. So my goal is to get this into milligrams per liter. So in order to go from moles to a mass, we need to use the molar mass. So we can go from moles to grams and grams to milligrams. That's great. So if you look up the molar mass of barium, because we have to use the molar mass of barium because we're starting with the concentration of the ionic species. So take moles of barium. How much does a mole of just the barium ions weigh? Because that's what the unit of parts per million. We want to know how much just barium 2 plus is in the solution. So if you look at the periodic table, so 1 mole of barium is off the periodic table is 137.3 grams of barium. So now my unit is in grams per liter, but we don't want that. We want to be in milligrams to get it to a ppm. So let's do 1 gram is 1,000 milligrams. So now the units cancel. Moles, barium cancel, grams of barium cancel. Now we're left with milligrams per liter. And so if you calculate this, we get that the concentration is 0.0832 ppm of barium 2 plus. So there is another answer. So we do the same thing for bromide. So start with the concentration of bromide. So it's different here. So we're going to start with 1.21. 1.21 times 10 to the negative 6 moles of bromide is in that 1 liter of solution. And again, we want to use the correct molar mass here. We're working in bromide, so we want to use the molar mass of bromide. So 1 mole of bromide is equal to 79.9 grams of bromide. Again, to get to ppm, we need it to be in milligrams per liter, so let's go from grams to liters. 1 gram, 1,000 milligrams. Plug that into your calculator, and you get 0.0968 ppm of bromide. And there is your second answer. Great. So I'll show you a little check here now. So since the only thing in solution is barium bromide. So if you add up the weight of barium and the weight of bromides, it should be equal to the amount of stuff you added to the original solution. So because in the original solution everything was put into exactly 1 liter, let's remember what a ppm is. It's 1 ppm is equal to 1 milligram in 1 liter. So if we take these two concentrations of ionic species, if we have 0.08 ppm of barium, that means in a 1 liter solution, there should be 0.0832 milligrams of barium. in a 1 liter solution, there should be also 0.0968 milligrams of bromide. So if we add those up, if we add those two values up, you should get 0.32 plus 0.0968. I get 0.18 milligrams. So if I convert that to grams, that is 1.8 times 10 to the negative 4 grams total. Look at the question. So this solution was prepared by dissolving 1.8 times 10 to the negative 4 grams of stuff. So it all works out in our concentration. So that's like a little check for yourself that it worked out. All right. So hopefully that helps. Yeah. So I'll just scroll through this so you can see all my work. And then the last part for ppm. This part's definitely a little tricky. All right. And then our little check that we did that everything worked out. All right, so hope that helps. Stick around for the last question.